What if I told you the most mind-bending leap in artificial intelligence this year didn't come from Silicon Valley, Beijing, or some billion-dollar lab, but from a small startup in Singapore most people have never heard of? And here's the kicker. Their AI isn't bigger, it's not trained on oceans of data, and it doesn't require a warehouse full of GPUs to run, yet somehow it's outsmarting models thousands of times its size. Sounds impossible. That's what I thought too. This system is called HRM, and it's so shockingly good at reasoning that veteran AI researchers are double-checking the math. You've heard the same AI story over and over. New model wins because it's bigger, trained longer, with more parameters. HRM rips that playbook in half and throws it out the window. This isn't a slimmed-down ChatGPT. It's not a lightweight transformer with a fancy marketing spin. It's an entirely different architecture, one that doesn't just process like a computer, but actually thinks in loops, closer to the way the human brain does. And here's the part that might make you spill your coffee. HRM has only 27 million parameters. For perspective, GPT-1, the ancient ancestor of today's giants, had 117 million. HRM is barely a quarter that size, yet it's outperforming modern models with billions of parameters and reasoning benchmarks. If you think this is just hype, think again. The results come from official published benchmarks, and they're not subtle wins. In some cases, HRM isn't just better, it's leaving its competition with a big fat zero. Over the next few minutes, I'm going to break down exactly how HRM works, why it's flipping the AI industry upside down, and why it might be the first real step toward AI that doesn't just imitate intelligence, but actually possesses it. One warning though, after you see how HRM works, you might never look at ChatGPT the same way again. Section 2, the status quo versus the disruptor. Before we dig into HRM's secret sauce, let's rewind and look at how most modern AI, including ChatGPT, handles reasoning. The dominant method is something called chain of thought prompting. Imagine the AI narrating its thought process like a student talking through a math problem step by step. First I'll do this, then I'll do that. Now I get the answer. Sounds clever, right? And when it works well. But here's the hidden flaw. If the AI makes one mistake in that chain, even something tiny, everything that follows is wrong. It's like baking a cake. If you accidentally add salt instead of sugar in step 1, the entire cake is ruined, no matter how perfectly you follow the rest of the recipe. This is where HRM takes a completely different path. Instead of building a single fragile chain of logic, it uses an iterative loop that constantly checks, corrects, and refines its reasoning before committing to an answer. Think less straight line and more feedback cycle. Most current AI models also have another limitation. They process every question with the same amount of thinking time, no matter how complex. Whether it's a simple trivia fact or a multi-step puzzle, the model does the same number of computational steps and spits out an answer. It can't decide, this one's tricky, I need to think longer. HRM, completely different story. It adapts. If the problem's easy, it solves it quickly. If it's hard, it loops more times, taking the extra time to reason things through. That's not just efficient, that's smart. We've been conditioned to believe that bigger is better in AI. More data, more parameters, more compute. But HRM proves there's another way. One that's not just about brute force, but about how the model thinks. So, how exactly does HRM pull this off with such a tiny brain? The answer lies in an architecture that's more like a human conversation between two minds than a single brain thinking alone. And once you understand it, you'll see why it's rewriting the rules. Section 3, the reveal. Here's the heart of HRM's magic. It's built around two core modules that talk to each other in a continuous loop, a high-level planner and a low-level worker. The high-level planner is like the slow, strategic brain. Its job is to look at the big picture, figure out what type of problem it's facing, and design a rough game plan for solving it. It's thoughtful, deliberate, and doesn't rush. The low-level worker is the speed demon. It takes the planner's instructions and executes them quickly and efficiently. It's not trying to strategize, it's just getting the job done. Now here's where it gets fascinating. These two aren't working in isolation. They loop. The planner hands a plan to the worker. The worker runs it, sends results back. The planner updates its strategy based on what happened. The cycle repeats until the system converges on the best answer. Think of it like a chess master, planner, and a lightning-fast assistant worker. The master decides on the next few moves. The assistant instantly makes them, reports back on the opponent's response, and the master adjusts the plan. This back and forth continues until victory. This is very different from a traditional AI model, which usually just generates output token by token without ever looking back to correct itself. Once a normal model starts writing, it's locked in. No takebacks, no rewrites midstream. HRM's loop design gives it something that's almost like metacognition, the ability to think about its own thinking. It can spot when a strategy isn't working and change course before committing to a final answer. And here's the kicker. This isn't a bolt-on trick or a clever prompt. It's baked directly into the architecture. That means HRM's entire reasoning process is inherently self-checking. It doesn't need to be told, now double-check your work. It just does. When you see the results this produces, you'll realize this isn't just an improvement. It's a paradigm shift, one that might make the old way of building AI feel primitive overnight. Section 4, the proof. All right, time for the part that makes skeptics sit up, the numbers. Because in AI, you can tell a great story, but if the benchmarks don't back it up, it's just marketing fluff. HRM's results, they're anything but fluff. Let's start with the ARCA AGI benchmark. Think of it like an IQ test for artificial intelligence. On this test, HRM scored 40.3%. For context, Anthropic's Claude 3.7 to 1.2%. OpenAI's O3 mini high model, 34.5%. HRM didn't just win, it crushed, and remember, it's a fraction of the size. Then there's Sudoku, not the easy kind you play on a Sunday morning, but hard and extreme puzzles. HRM solved 55% of them. You know how many Claude or O3 mini high got? 0. Not a single one. That's not a small gap. That's the kind of result that makes you double-check your testing code. And it doesn't stop there. In the 30 Ups 30 Maze Challenge, HRM found the optimal path in 74.5% of cases. The others? Again, 0. If this were a sports match, the referee would have called it a mercy rule. Oh, and get this. HRM was trained with just 1,000 examples per task. That's nothing compared to the massive data sets today's AI models gorge on, and it still managed to beat giants. Guan Wang, one of the minds behind HRM, says you could train it to professional-level Sudoku in just 2 GPU hours. 2 hours. These aren't cherry-picked tricks. This is the result of HRM's core design, the looped planner worker feedback that lets it adapt in real time. When other models lock themselves into a bad solution, HRM just tries again. It's not just better results, it's better reasoning. And that's the dangerous part for the AI giants, because you can't just throw more GPUs at a problem like this. You'd have to rebuild your model from the ground up. Section 5, the deeper innovation. Now let's zoom out and talk about why this architecture is such a threat to the old guard. Most transformer-based models like GPT or Claude do a fixed number of reasoning steps per token, whether they need them or not. They can't say, this is tricky, I'll think a little longer. Once they start outputting text, they're committed. Every word is written in ink, no rewrites allowed. That's like trying to solve a complex math problem 1 digit at a time, in pen, without ever checking your work. If you mess up early, too bad, you're stuck with the wrong answer. HRM breaks free from that prison. Because of its planner/worker loop, it can dynamically decide how long to think based on the problem's difficulty. Simple task, a couple of loops. Nightmare puzzle, more loops, deeper reasoning. This flexibility makes it feel less like a program and more like, a thinker. And here's something the AI research community is buzzing about. HRM doesn't require deep backpropagation through time, a memory-heavy, slow, and biologically questionable process used in most models. Instead, it uses local gradient updates, which are faster, more efficient, and arguably more brain-like. Why does that matter? Less memory means it's cheaper to run and easier to scale. It means you could fit HRM onto smaller devices, even laptops or embedded systems, without losing performance. And in AI, efficiency isn't just nice to have, it's a weapon. The moment you can deploy cutting-edge reasoning without needing a data center, you change the entire economics of the field. This is the kind of shift that can turn a tiny startup into a market leader almost overnight. And that's exactly why HRM's approach has the big players paying attention, even if they're not admitting it publicly. Section 6, real world and future. So what happens when you take an AI that's this small, this efficient, and this smart, and let it loose in the real world? The team behind HRM, Sapien, is already testing it in high-stakes environments. In healthcare, HRM is being used to help diagnose rare diseases. Sifting through symptoms and medical histories to spot patterns even seasoned doctors can miss. In seasonal climate forecasting, it reportedly hit 97% accuracy, predicting weather patterns months in advance. And remember, this is running without massive server farms. That means the potential for local AI systems that live directly on your laptop, your robot, even your car, no cloud connection required, no privacy compromises. The people behind this aren't random newcomers either. Sapien's team includes engineers from DeepMind, Anthropic, DeepSeek, and even Elon Musk's xAI. These are veterans of the AI frontier, and they're all betting that brain-inspired architecture is the way forward. Their vision is clear: machines that don't just mimic human conversation, but actually reason like human beings, and eventually beyond human beings. This isn't to say HRM is perfect. It's not built to chat like GPT. It's focused purely on reasoning, on solving problems. But as a proof of concept, it's one of the strongest we've seen in years. And it's part of a broader trend. Sakana is working on continuous thought machines. Some labs are experimenting with 1-bit weight models. And even Google is testing diffusion-based reasoning. The race isn't just about scaling anymore. It's about rethinking AI from the ground up. What's different here is that HRM isn't just theory. It's already delivering results. And that means the old rules about bigger is better might be about to collapse. Section 7, closing. So here's where we're left. HRM is a tiny brain-inspired AI that's out-reasoning models 4 times its size, using a fraction of the data with almost no pre-training. And it's open source. Anyone can download it right now, peek under the hood, and even train their own. If the current trend holds, the next AI revolution won't come from a bigger GPT clone. It'll come from something like this, an architecture built for thinking, not just talking. And when that shift happens, the impact will be huge. Imagine AI assistants that live entirely on your laptop, reasoning through complex tasks without touching the cloud. Imagine robotics powered by a brain small enough to fit in your palm, but smart enough to adapt on the fly. This isn't decades away. It's here, in a small Singaporean startup's GitHub repo. And if history teaches us anything, it's that revolutions rarely start in the biggest offices. But now I want to hear from you. If AI can already out-reason some of the most powerful models in the world at a fraction of the size, what happens when architectures like HRM scale? Are we looking at the first real step toward artificial general intelligence? Or is there another leap waiting just around the corner? Drop your thoughts in the comments. I'm reading every single one. If you want to stay ahead of the next big AI breakthrough, hit that subscribe button, smash the like, and turn on notifications, because the next story we cover might just be the one that changes everything.